Okay, so let us solve now the second example about our topic called slope. So our second example is something like this. Find the equation of the tangent line to the graph of f of x equal to 6x minus x squared at x equal to 1. Okay, and the other one is also find the equation of the normal line to the graph of f of x equal to 6x minus x squared at x equal to 1. So like in our previous discussion, the best way to solve this problem is to first graph. Let us graph the function so that we can see the picture or how this graph of this function looks like. Okay, so the one of the way to graph the function is to take some values for x and then solve for f of x. Alright, so for example, if x equal to, if you assume from the number line, if you have the number line, okay, you just consider this, for example, this horizontal line here. So we have here 0, the origin, intersection of x and y axis. So we can take this number line as our reference. Okay, so for example, you consider the interval from -2 to +8. Okay, so let us assume values that belongs to that interval. Okay, so say for example, if we let x be equal to -1, so what will be our f of x? So we have to look at this function. So 6 times -1, that is -6, minus -1 squared, so that is 1. So -6 minus 1, so we have -7. Alright, if x equal to 0, so at this point here, okay, so at x equal to 0, so what will be our y? So again, referring to that equation of the function, so when x equal to 0, so this will be 6 times 0 equal to 0 minus 0 squared, so that is also equal to 0. When x equal to 1, okay, so when x equal to 1 here, so what will be our f of x? So when this is 1, so 6 times 1, 6 minus 1 squared equal to 6 minus 1 squared. 1 squared is 1, so equal to 5. Now when x equal to 2, so this will be 6 times 2, 12, minus 2 squared, 4. So 12 minus 4. So when x equal to 2, so our f of x equal to 8. Now when x equal to 3, so when x equal to 3, so this is 6 times 3, 18, minus 3 squared, 9. So 18 minus 9, so equal to 9. When x equal to 4, so 6 times 4, 24, minus 4 squared, 16. So 24 minus 16, that is 8. Then when x equal to 5, so 6 times 5, 30, minus 5 squared, 25. So 30 minus 25 equal to 5. Okay, by the way, when x equal to 4, 24 minus 16. This is correct, that is 8. Now when x equal to 6, so when x equal to 6, so 6 times 6, 36, minus 6 squared, 36 also. So 36 minus 36 is equal to 0. And when x equal to 7, when x equal to 7, so 6 times 7, 42, minus 7 squared, 49. So 42 minus 49 equal to minus 7. Okay, so now let us plot the points. So these are pair of x and y values, so that corresponds to points. So for example, if you have x equal to 1, when x equal to 1 or negative 1, so when x equal to negative 1, so we have y equal to, our f of x, y equal to f of x equal to 7. So negative 1, then our f of x equal to minus 7, so the point should be here. When x equal to 0, so the point should be here, right? Now when x equal to 1, so our f of x is 5. So x equal to 1, so f of x equal to 5. So it should be somewhere here. Now when x equal to 2, so our f of x is equal to 8. So 2 and 8. Alright, so it should be here. When x equal to 3, so when x equal to 3, so f of x is 9. Okay, so it's somewhere here. Then when x equal to 4, so we have 8. Now when x equal to 4, we have 8. Our f of x is 8. So it should be here. When x equal to 5, so f of x is also equal to 5. So it's somewhere here. When x equal to 6, f of x is equal to 0. So it's here. And when x equal to 7, so when x equal to 7, here, our f of x is negative 7. So it's down here. Okay, so it's minus 7. So when x equal to 7, so our f of x is somewhere here, negative 7. Okay, now connecting the points. So when you connect the points, alright, so we can put arrow to indicate that if you put more values for x to the left or to the right, so you still have a corresponding values for f of x. Okay, so this is the picture of the graph of the function. Alright, so going back to the problem, so at least you know now what's the picture of the graph. Okay, so we are asked to solve for we are asked to find the equation of the tangent line to the graph of f of x at x equal to 1. So our solution here, first we need to look at the where's the point, where's the point that the line is tangent to in our graph. So we have to solve for the value of the function at x equal to 1. At x equal to 1. So what is the function? The value of the function. So f of x at x equal to 1. So we have f sub 1. So substitute this to our function. So we have to replace this x by 1. So this will be 6 times 1. Then minus 1 squared. Okay, 1 squared. So equal to 6. 6 times 1, 6. Minus 1 squared. 1 squared is 1. So 6 minus 1 equal to 5. So we can say that the point. So from the graph when x equal to 1, our f of x is this one. Okay, so this is the point where the line is tangent to. Okay, so we can let this point be our P1. Okay, so if this is our P1, we have the coordinates x1, y1. Then we can say that our x1, so this is the given x, right? So our x1 at this point is equal to 1. Okay, then our y1 at this point, this will be, or this is equal to 5. So we will be using this later on. Alright, so going back to our solution, we have to do the same thing as what we did in our example number 1. So what is it? How did we solve problem or example number 1? So we had started with writing our function, which is f of x equal to 6x minus x squared. Alright, then to solve for f prime of x, so f prime of x, we have to use the formula of, or the formula that we had derived before. No? We have the limit of f of x. Our f of x is, or let's write first the formula. Limit of f of x plus delta x minus f of x divided by delta x as delta x approaches to 0. Okay, so this is our formula, and then we have to change. No? We have to change x. No? Change x to x plus delta x. Okay, so change x to x plus delta x. So from this function, alright, so we have to change x to delta x. So therefore our f prime of x is equal to, we have 6, 6, or this is limit of, we have 6 x. Our x should be changed to x plus delta x. Then minus x squared, minus x squared. So minus x squared. So our x is changed to x plus delta x. So x plus delta x. So this is our x changed to x plus delta x. So we have to square that also. Okay. Then from this formula, minus, we have minus f of x. So what is our f of x? So our f of x is this one, right? So f of x equal to 6x minus x squared. So since we have two terms here for our f of x, so we have to enclose this with a parenthesis. So minus, we have 6x minus x squared. Okay? Divided by delta x. As delta x approaches to 0. Okay? So next, we are going to distribute 6. Okay, so distribute 6 and multiply to each term of this quantity. Alright? And then this one here, we have to expand this first. This is a binomial. Okay? So we have power 2, or exponent is 2, so we have to expand this one. And this one, this is negative, so you have to multiply each term by negative. So understood, it has 1 here, so negative 1. So negative 1 multiplied by 6x. So you have to distribute this and multiply. And be careful of the sign. Okay? So limit of, so when you multiply this, so we have 6x, then plus 6 delta x, then minus, so don't forget to enclose it with a parenthesis, otherwise your answer will be wrong. Okay, so the rule in binomial, if you have say u plus v squared, this is equivalent to u squared, so square of the first term, then plus twice the product of the first and second term, so 2uv, then plus square of the second term, so you square the second term, v squared. So we have to follow this equivalent when you expand this u plus v squared. We have x plus delta x squared, so we have to follow that equivalent. Okay, so we have our first term, and this quantity is square of the first term, which is x squared, then plus twice the product of the first and second term, so twice the product. So product of x and delta x is x delta x. Twice means 2 times, so 2x delta x, then plus square of the second term. So our second term is delta x, so we square this one, and then don't forget to put it inside a parenthesis. Then minus, so distribute this, negative times 6x, so negative 6x. So this is understood to be, or to have 1 here. So negative 1, you can think of it as negative 1 times 6x, negative 1 times negative x squared. So negative and negative, so that is plus x squared. Okay, now we have removed the sign of groupings. Then divided by delta x. Okay, as delta x approaches to 0. So equals, so limit of the function as delta x approaches to 0. Right, so we have 6x plus 6 delta x, then minus, so this time you have to distribute and multiply also this, so understood to have negative 1 here, or you just simply multiply each term by this negative, then consider the sign. So negative 1 understood to be, or to have 1 here, negative 1 times x squared, so you have negative x squared. So negative 1 times positive 2x delta x, so this will be negative 2x delta x. Okay, so while you are doing this class, you have to remove the sign of grouping, this parenthesis, the external. Okay, then negative 1 times positive delta x squared, so this would be negative delta x squared. Then you just copy this one, 6x plus x squared. So now you have removed the sign of groupings here, except this one. No, we just put it inside the parentheses just to tell us that delta x, so this is 1, considered as 1. Otherwise, if you will not put this parenthesis, so it can be interpreted as delta then x squared. So better put it inside the parenthesis, divided by delta x as delta x approaches to 0. So now let's look at the numerator. So at the numerator we have similar terms, so we can combine them. So for example, we have positive 6x. Okay, so we have positive 6x and we have negative 6x here. So combining, this will be 0. 6x minus 6x, 0. We have negative x squared. We have positive x squared. So when we combine them, minus x squared plus x squared, so this is also equal to 0. So what is now left in our numerator? So again, rewriting it. So we have limit of the function as delta x approaches to 0. So we have 6 delta x, 6 delta x, then we have minus 2x delta x, then minus delta x squared divided by delta x as delta x approaches to 0. Now if you look at the numerator class, we can find, or we can see that there is a common factor. Okay, so what is the common factor here? So if you look at its term, so we have first term, it has delta x. Second term also has delta x. Third term also has delta x, but it's squared. So factoring out common factor, which is delta x, okay, and divide its term by the common factor, it means 6 delta x divided by the common factor delta x. So what is left? So we have 6 minus, this is minus, so 2x delta x divided by delta x, so we have 2x, then minus delta x squared divided by delta x, so we have delta x, then divided by delta x. Now looking at the numerator and denominator, so we have delta x divided by delta x, so this will be equal to 1, right? So this is equal to 1. Okay, so you can either put 1 here at the numerator and at the denominator, it doesn't matter. So what is left in our expression is limit of, we have 6 minus 2x minus delta x as delta x approaches to 0. Alright, now substituting delta x, or plugging in this value of delta x to our expression, so we have 6, so this will be 6 minus 2 x minus 0. So therefore our f prime of x is equal to 6 minus 2x is equal to 6 minus 2x. Okay, so this is our f prime of x, which is our, in our derivation last time, this is our slope of the tangent line. Okay, so slope of the tangent line is equal to f prime of x equal to 6 minus 2x. Okay, so now looking back to our graph. So our graph here. So where is our tangent line? So our tangent line should be this one, because it's mentioned the problem to the graph of at x equal to 1. So this is at x equal to 1. This is our f. This is the point. This is our value of the function. So our tangent line should be this one. Sorry, it's not well done, but it should be. It should touch only at that point. Okay. So what is the equation of this line? So we are asked to solve for the equation of this tangent line. Okay, so that's the problem. Now we already have solved the slope, right? So we already have solved the slope, but that is in terms of x. So the slope at x equal to 1. Okay, so at p1, no, at x equal to 1, meaning at this point p1, our x equal to x1 equal to 1. So we can solve for the slope. So slope, which is MTL, the slope is equal to the f prime of x equal to 6 minus 2x. Okay, substituting. So slope of the tangent line equal to 6 minus 2 times x equal to 1. So slope of the tangent line is equal to 4. Okay, so we have solved the slope of the tangent line. Now, how to find the equation of the tangent line? So to solve for the equation of the tangent line, we will apply the what we call points law form. So what is points law form, class? And when can we use this points law form? So we can use this to find the equation of the line, in this case equation of the tangent line, if we are given, or if a point is known and also the slope is known. But we know from our graph that our point is known already from our calculation. So it's known already. So we have our point P1 with coordinates x1, y1. In this case, we have our x1 is 1, our y1 is 5. Okay? And now we have calculated the slope of the tangent line. So what is points law form? So the points law form is y minus y1 equal to m times x minus x1. Okay? So from this equation, the points law form, so we can use that y minus y1 equal to m, but our slope is slope of the tangent line, TL, MTL, which is equal to 4. But now let's write this equation first. So m times, or MTL times x minus x1. What is our MTL? So this is already solved, which is equal to 4. Then we have P1, x1, y1 equivalent to 1 and 5. So substituting this, so we have y minus, our y1 is 5 equal to MTL is 4, then x minus x1 is 1. So y minus 5 equal to distribute and multiply. So we have 4 times x is 4x, 4 times minus 1 is 4. Now we have to follow the standard form of the equation. This is a line. So the standard equation or the general form of the line, ex plus by plus c equal to 0. So our answer must take this form, class. Okay? So it means that one side of the equation should be 0. And let's make the x, or the term that contains x, should be positive. Though it's not wrong, no, if this is negative, it's not wrong. So in this case, let's make the other side 0. So let's transpose this one, or you can subtract both sides or add both sides by 5 and subtract both sides by y, or simply you just transpose it to the other side. So the left side is 0, so we have 4x minus 4. When you transpose y, that becomes minus y. Minus 5 becomes plus 5. Okay, and then rearranging. So 0 equal to 4x, then followed by y. So minus y, we have minus 4, and we have positive 5, so this is plus 1. Okay, or you can rewrite this as 4x minus y plus 1 equal to 0. So this is the equation of the tangent line. This is the equation of the tangent line. Okay? Now, what is the second question? The second question is, we also have to find the equation of the normal line. So what does it mean, normal line, class? So normal line means that is the line that is perpendicular to the tangent line. So this is our tangent line here. Okay, so this is our tangent line. So what is the position of our normal line? So our normal line should be perpendicular to this tangent line and also passing to this point. Okay, so normal means this is they will form 90 degrees between this line and this tangent line. So this is the normal line. Okay, so we are also asked to find the equation of this. Okay, so how to solve or find the equation of the tangent line? So there is a relationship between the slope of the tangent line and the normal line. So what is it? So the relationship is something like this, class, that the slope of the normal line, so if we let that mn be the slope of the normal line, so its relationship to the tangent line or the slope of the tangent line is something like this. Slope of the normal line is equal to the negative reciprocal of the slope of the tangent line. So let's call it NL for normal line. We have tangent line for the TL. Okay? So from this relationship, we can also find the equation of this line here, this normal line. Alright, so first we have to solve for the slope of the normal line. Or you can simply substitute directly to the point slope form. Again, from the point slope form, because this line also passes through the point, same point as the point that the tangent line passed through. So you can also use the point slope form. So from point slope form, So we have y minus y1 equal to m. So this time we have m of the normal line times x minus x1. Okay? So substituting y minus y1, our y1 is equal to 5. No? Same as the y1 that we use in our tangent line. So slope of the normal line is the negative reciprocal of the slope of tangent line. What is the slope of tangent line? Slope of the tangent line is 4. So MTL here, this one is 4, slope of the tangent line. So negative reciprocal of that is negative 1/4. Okay? So times x minus our x1 is 1. Okay? Now, again, we have to express our answer in terms of this form. So same as the tangent line, ax plus by plus c equal to 0. So we also have to express our equation in that form. So from here, you can cross multiply 4, or you can multiply both sides by 4 just to eliminate the fraction. So multiply both sides by 4. So we have 4 times y equal to 4y minus 4 times 5 equal to 20 equals 1/4 times 4, so that becomes 1. So you have negative. So you have negative 1 times x minus 1. Okay, distributing this and multiplying each term by negative 1. So we have negative x plus 1. So 4y minus 20. Okay, then since x is negative, let's transpose this to other side, and then 1 also transpose to the other side, and then write it first. So when negative x transposed to other side, so this becomes positive. Okay, then followed by plus 4y, then minus 20, then we have minus 1 equal to 0. You transpose this, that becomes negative. Then combining, so x plus 4y minus 20 minus 1, so minus 21 equal to 0. So this is the equation of our normal line. Okay? So that's the solution of this problem. So I hope you have followed class and our discussion. So we started with this problem. Okay? And this is our solution. Or before that one, we have graphed the function. So this is the graph of the function. Okay, so after graphing the function, we have solved this problem using this process. Okay, and we have we have found the equation of the tangent line using the point slope form. Okay, and we express the answer in terms of, or following the form of ax plus by plus equal to 0. Alright, and then we have solved the equation of the tangent line, which is 4x minus y plus 1 equal to 0. And for the normal line, we have x plus 4y minus 21 equal to 0. If you look at the tangent and normal line class, if you can still remember from your analytic geometry, so you see here we have 4x minus y, and then we have x plus 4y. So that indicates that these two equations are perpendicular to each other. Okay, so I hope you were able to follow the process in solving this problem. And thank you very much, and see you again in the next video. Bye bye for now.